Okay, I want to talk separately about asymptotes. I talked about it when I constructed these graphs, but I want a separate video about asymptotes. So we saw when we first constructed these graphs, and we said it, that as, for example, in this graph, as x gets closer and closer to 0, x gets tinier and tinier. So 1 over x gets bigger and bigger because 1 divided by x is how many tiny x's go into 1. Okay, how many little tiny numbers do we need to make up 1? The numbers get unrestrictedly tiny, which means that the values of x get the values of y equals 1 over x get unrestrictedly great. So that as we take points closer and closer and closer to 0, we get points that are higher and higher. Since there's no limit to how close we can get to 0, there's no limit to how high. So we have the function, as we say, approaching infinity as x approaches 0. The graph gets closer and closer to the y-axis, but it never meets it. Even though if you draw it, it looks like it does, because the line has some thickness, and pretty soon the two lines will almost join up. The actual lines have no thickness, they never actually join. So this curve here never actually joins with this line, even though when you draw it, it looks like it. Okay, and similarly over here. And similarly here and here. And here, you go off to infinity, this thing goes up much faster, because when you square a tiny number, you get a really tiny number. If you square 1/10, you get 100th. If you square 1,000th, you get a millionth. Okay? So this goes up much faster, but it eventually appears to join up with the y-axis if you draw it with actual matter. Okay? Now you have horizontal asymptotes. Okay? For this function, you have the horizontal asymptote, but well, let's take this one. 1 over x, we don't have to worry about big squaring numbers and stuff. When x is 3, 1 over x is 1/3. So if x is 3, here the value of the function is 1/2, here the value is 1/3. If x is 4, it goes down to 1/4. So you go to 1/3, 1/4, 1/5, 1/6. These y values are approaching 0, and the y values on this side are also approaching 0 from below. Okay? These are horizontal asymptotes. You're approaching the x-axis more and more closely, but never reaching it. And you have horizontal asymptotes here. This one flattens out a lot faster than this one does because of the squaring of the x. Okay. For the exponential function, this one actually flattens out even faster than those do. By the time you get to -3, -4, -5, 2 to the -5 is 1 over 32, and 1 over 5 squared is only 1 over 25. Okay? Don't necessarily need to think too hard about that, because we'll talk about it later. But just justifying the fact that this thing actually goes to 0 faster than either of these. And you get the horizontal asymptote. Okay? So that's what we mean by asymptotes, and that's a fairly complete description of what an asymptote is.